Today we are going to discuss some math puzzles, and the way I have structured this video is first I'll display a couple of puzzles and you can think over it, and while we discuss over the question after a couple of minutes later in the video I would discuss the answers as well, and in the end I will give you a bonus question and that we can discuss in our follow-up video. So let's get started with the first one. So here, as you see, I start by saying let x plus y equal to z, and then I am changing this equation by adding x and y on both sides, and that gives me 2x plus 2y is equal to x plus y plus z. Well, now I subtract 2z on both sides, that gives me 2x 2y minus 2z is equal to x plus y minus z. Awesome. Why don't we take the 2 common out? If I do that, that gives me 2 times x plus y minus z is equal to 1 times x plus y minus z. Then I cancel the common on both sides, which is x plus y minus z. That gives me 2 is equal to 1. What? How come? How is this possible? 2 is equal to 1. Let's think over it while we go to the next slide. Here, everyone knows 1/8 is always less than 1/4. That's for sure. That's right. Okay. We can write it in various different form. Let's write it in the form half cube is less than half square, which is also perfect. Then I can confirm or transform this into logarithmic form by taking logarithm on both sides. That gives me log of half cube is less than logarithm of half square. Well, of course, we can bring the power term, which is either 3 or 2. I can bring it in the front by the fundamental logarithm definition. Then I can write that as 3 log half is less than 2 log half. Wow, I have log half on both sides. Let's cancel that. Once I cancel it, I have 3 is less than 2. I can't believe this. How can 3 be less than 2? Think it over. Now let's go move on to next question. Yes, finally this is easy. How can we sum up all these terms, which is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, all the way to 2 to the power of n? Is there a easy way to do this? Now let's move on to the solution. If you notice on the first question, I had started by saying x plus y is equal to z. That being said, x plus y minus z is equal to 0. Then how can we cancel 0 on both sides? This is like writing 2 times 0 is equal to 1 times 0, which we all agree, which is 0 is equal to 0. Then we should not cancel both these 0 and say 2 is equal to 1. That's the reason whenever we cancel any information, we need to confirm whether it's a valid cancellation. And this was a trap where we cancel 0 on both sides and finally which gives us 2 equal to 1. Watch out for these kind of traps in future. Now look into the next one. Here, whenever you have a inequality and you are cancelling it, make sure the information that gets cancelled is a positive number. So if you see logarithm of half is actually a negative number here. So whenever you are multiplying or dividing by a negative number in an inequality, we need to flip the sign. So as per that, when you flip the sign, 3 log half less than 2 log half, after the cancellation, it should become 3 is greater than 2. So that was a second trap where we have a negative number inside log of half, and that negative number is getting cancelled, and that puts us in a position which is not accurate. Let's move on to next one. Of course, coming to this one, when you want to sum up all these numbers, if you watch carefully, this is a geometric sequence where 2 square, where you multiply by 2 for every term. Well, if it is a geometric sequence, we can always use geometric sequence formula, but I want to think outside the box. Let's think of a binary world where every number is represented either in 0 or in 1. In that case, 2 power 0 is equal to 1, 2 power 1 is written as 1 0, and 2 square is written as 1 0 0, and 2 cube is written as 1 0 0 0. And if we need to add these four numbers in a binary world, that will give us 1 1 1 1. Well, we can extend this further, and if we have to do all the way till 2 power n, then here if you notice we and let's call this whole summation as x, which I'm not sure whether I told you in the beginning. So x is going to be equal to 1 1 1 n times. So that whole big number in a binary world is the sum of these. Now, if you add 1 on both sides, what will happen is you come to this and you add 1 to the last digit on the right hand side. That 1 will become 0 and it will carry over the 1 to the next one, and that will also become 0 and carry over 1 to the next, and this process keeps continuing till the end, and the last one will also turn 0 and carry over 1 after that. So that will give us 1 followed by n number of zeros. Nice. So now we have x plus 1 is equal to 1 followed by n zeros in a binary world. Now, why not we subtract 1 on both sides? That gives us x is equal to 2 power n minus 1. Nice. So we were able to sum up all of these in a binary world. And of course, we can do this in a simple geometric sequence as well. Let's confirm that. And here we have a, which is the first term, is 2 power 0, which is equal to 1. And the ratio is the ratio between any two term, which is r, and the ratio here is 2, because at every step or every term we are multiplying by 2. And now the sum of geometric sequence formula is a r to the power of n minus 1 whole divided by r minus 1. So once we put in our plugs, and we have 2 power n minus 1 divided by 1, which is 2 power n minus 1, which matches with what we did in a binary world. Of course, whether you do the calculation in a normal world where we live in, or in a binary world or any other system, it should give the same answer. Okay, here is the bonus question for the next video. Let's say we have two dice which is plain, that means nothing is written on it. And this die, both of them have 6 faces. And what I want you to do is take a pen and write any number on it. You can write 1, you can write 36, 24, any number you want. Write any 6 number on each of these dice, and when I roll it, I should get all possible combination from 1 to 36. That's the puzzle for today. Think it over, and I will discuss with you in the next video. And if you like this video, please go ahead, give me a thumbs up, and do subscribe to my channel for future updates. Thank you.